Welcome to Elevate Learn. In this tutorial, we're diving into 3 of the most powerful and essential array methods in JavaScript: map, filter, and reduce. These functional programming techniques will transform how you work with arrays and write cleaner, more efficient code. Whether you're processing data, filtering lists, or computing aggregate values, mastering these methods is crucial for any JavaScript developer. By the end of this video, you'll understand not just how these methods work, but when and why to use them in real-world scenarios. Let's get started. Traditional loops work, but they're verbose and harder to read. Array methods like map, filter, and reduce represent a shift toward functional programming in JavaScript. They allow you to express what you want to do with data in a clear, concise way. Instead of managing loop counters and manually pushing items to new arrays, you declare your transformation. This approach reduces bugs, improves readability, and makes your code more maintainable. These methods are now fundamental to modern JavaScript development, used in frameworks like React and found in virtually every professional codebase. Understanding them is no longer optional, it's essential. The map method is your go-to tool when you need to transform every element in an array. It takes a callback function and applies it to each element, creating a brand new array with the transformed values. The key point here is that map always returns an array of the same length as the original. If you start with 5 elements, you'll get 5 elements back. Map is perfect for scenarios like converting data types, extracting properties from objects, or performing calculations. Remember, map doesn't modify the original array, it creates a new one. This immutability is a core principle of functional programming and helps prevent bugs. Let's look at practical examples of map in action. One of the most common use cases is extracting properties from an array of objects. Imagine you have user data with names and ages, and you need just the names for a drop-down menu. Rather than looping manually, you can simply map over the array and pull out the name property. You can also perform calculations on the fly, like doubling everyone's age. Map becomes even more powerful when you chain it with other methods, creating pipelines of data transformations. The flexibility here is remarkable. You're not limited to simple property extraction. You can call functions, perform calculations, or even create new objects based on the original data. Filter is your tool for selecting specific elements from an array based on a condition. Unlike map, which always returns the same number of elements, filter can return fewer elements or even an empty array. The callback function in filter must return a Boolean value, true if you want to keep the element, false if you want to exclude it. This is incredibly useful for searching, sorting by conditions, or removing unwanted data. For example, you might filter an array of products to show only items under a certain price, or filter user accounts to find all active users. Filter is simple but powerful, and it's one of the most frequently used array methods in real applications. When working with arrays of objects, filter becomes even more valuable. You can check multiple properties and combine conditions with and or operators. For instance, with a product array, you might want to show only affordable items that are in stock. Filter lets you do this elegantly in a single line. You can also create reusable filter functions by extracting the logic into separate functions, making your code more modular and testable. Another powerful technique is chaining filter multiple times to gradually narrow down your results. This creates a data pipeline that's easy to read and understand. Filter is the foundation of building responsive user interfaces where data changes based on search criteria. Reduce is the most powerful and, admittedly, the trickiest of the 3 methods to understand at first. But once it clicks, you'll realize its versatility is unmatched. Reduce takes every element in an array and reduces it to a single value. It works by maintaining an accumulator that gets updated as you iterate through the array. The callback receives the accumulator and the current element. You start with an initial value for the accumulator, then update it with each iteration. The final value of the accumulator is returned. You can use reduce to sum numbers, multiply values, build objects, or even count occurrences. It's the most flexible method because you control what the final value is. It can be a number, string, object, or anything else. Let's walk through reduce step by step so you really understand what's happening. We start with an array of numbers and an initial accumulator value of 0. On the first iteration, the accumulator is 0 and the current number is 1. We add them, getting 1, which becomes our new accumulator. On the second iteration, the accumulator is now 1 and the current number is 2. We add them, getting 3. Finally, the accumulator is 3 and the current number is 3. We add them, getting 6, which is our final result. This tracing process is crucial for understanding reduce. I recommend doing this manually a few times until the pattern becomes clear. Once you see how the accumulator flows through each iteration, reduce becomes intuitive and powerful. Reduce truly shines when you move beyond simple arithmetic. One powerful use case is counting occurrences of items. Given an array of words, you can use reduce to build an object where keys are the words and values are their counts. Another common pattern is grouping data. With an array of users, you can reduce it into an object organized by user role. This is incredibly useful for preparing data for the front end where you need structured, organized information. You can also flatten nested arrays using reduce, or build complex data structures from simple arrays. The key insight is that the accumulator can be any data type, a number, string, object, or array. This flexibility makes reduce applicable to almost any data transformation problem you'll encounter. One of the most elegant patterns in JavaScript is chaining map and filter together. The typical approach is to filter first to narrow down your dataset, then map to transform the remaining elements. This makes your intent crystal clear. First, select matching items, then transform them. It's more efficient than the reverse order because you're doing fewer transformations. In the example, we start with a user array, filter to only active users aged 18 or older, then map to extract just their names. The beauty of this approach is readability. Anyone reading this code immediately understands what's happening. Filter the data, then transform it. This pattern is used constantly in real applications, especially in React where you're rendering filtered and transformed data. Combining filter and reduce is perfect for calculating totals, averages, and other aggregations on subsets of data. First, filter your array to include only items matching certain criteria, then reduce to calculate an aggregate value. In this example, we're calculating the total amount from only completed orders. The filter narrows the dataset to completed orders, and the reduce sums up their amounts. This pattern is essential for building dashboards, reports, and analytics features. You might filter orders by date range and calculate totals, filter products by category and find the average price, or filter transactions by type and compute sums. This combination is incredibly practical and appears constantly in real-world applications. Now let's see how powerful it becomes when you combine all three methods. Filter selects the transactions you care about, map extracts just the amounts, and reduce sums them up. This pipeline is readable, efficient, and expresses your intent clearly. You're not managing any loops or intermediate variables. The data flows through each transformation step, becoming more refined at each stage. This is the essence of functional programming in JavaScript. In real applications, you might have more complex conditions in filter, more sophisticated transformations in map, and various aggregations in reduce. The pattern remains the same. Select, transform, aggregate. This approach scales beautifully, handling both simple and complex data processing tasks with clarity and elegance. When using these methods, watch out for common pitfalls. First, always provide an initial value to reduce. Without it, the first element becomes the accumulator, which can lead to unexpected behavior and bugs. Second, never mutate the original array inside map, filter, or reduce. These methods create new arrays or values, preserving the original data. Mutating goes against functional programming principles and can cause bugs. Third, make sure your filter conditions are correct. A simple logic error will silently exclude or include wrong elements. Finally, be aware of performance with very large datasets. While these methods are optimized, they still iterate through the entire array. For massive datasets, you might consider more specialized approaches, but generally, the clarity gained by using these methods far outweighs any minor performance cost. While map, filter, and reduce are generally efficient, Understanding performance implications helps you write better code. Each chained method creates an intermediate array, which uses memory. For most practical purposes, this is fine, but for huge datasets, it matters. A useful optimization is to filter before mapping. If you filter first, you reduce the number of items that need transformation, saving work. Another tip is to be mindful of operation complexity. Filtering by a simple property is fast, but calling an expensive function in the callback slows things down. For extremely large datasets or performance-critical code, you might use a single for loop instead of chaining methods. However, for typical application code, the clarity and maintainability gains far outweigh any minor performance costs. Always profile with real data before optimizing. Good news! You don't need to worry about compatibility. Map, filter, and reduce are ES5 standard methods, which means they've been supported in all browsers for over a decade. Even Internet Explorer 9 supports them. If you're building modern web applications, you can use these methods freely without any polyfills or compatibility checks. They're also available in Node.js, so you can use them in both server-side and client-side JavaScript. The only exception might be if you're supporting very old environments, but that's increasingly rare. The wide compatibility of these methods makes them safe choices for any JavaScript project. They're not new or experimental features. They're well-established, battle-tested, and used by millions of developers worldwide. Let's apply these methods to a real-world scenario. Building an e-commerce platform. You have a product catalog and a shopping cart containing product IDs. To calculate the cart total, you map each ID to the full product object, then reduce to sum the prices. For the product browser, you filter by category and price range, then map to extract just the names for display. These exact patterns appear in production e-commerce code everywhere. The clarity of this approach makes features easy to understand and modify. If requirements change, like adding a discount, you simply add another step to the pipeline. The flexibility of these methods makes them perfect for real-world applications where data structures and requirements constantly evolve. Real-world data is often nested and complex. API responses frequently contain arrays of objects, which contain their own arrays. These methods handle nested structures beautifully. To flatten nested arrays, map extracts each inner array, then reduce concatenates them into a single flat array. This is common when processing API responses or database results. You can also map over a collection and perform reduce operations on each inner array, like calculating averages or sums. This technique allows you to extract insights from complex nested structures. For example, from a dataset of users with their test scores, you can easily compute each user's average while flattening all scores into a single array. The ability to compose these methods for nested data is one of their greatest strengths. Writing clean code with these methods is as much art as science. When your filter or map callback becomes complex, extract it into a named function. This improves readability and makes your code testable. Named functions like isActiveAdult immediately convey intent. Rather than a cryptic conditional, you have self-documenting code. Another tip: chain multiple filter calls instead of combining conditions with and operators. This makes each filter's purpose clear and each filter independently testable. You can also extract the entire transformation pipeline into a named function, making it reusable and allowing you to compose complex operations from simpler ones. This functional programming approach results in code that's easier to understand, maintain, and test. Remember, code is read far more often than it's written, so optimize for clarity. For advanced use cases, reduce becomes incredibly powerful. You can use it to build analytical structures that aggregate and organize data simultaneously. In the example, we create a department analysis showing count and average salary per department in a single pass through the data. This is more efficient than multiple separate operations. Advanced developers also use reduce to implement utility functions like compose, which chains function calls together. These patterns emerge naturally as you become more comfortable with reduce. They represent a deeper shift toward functional programming. As you progress, you'll find reduce enables patterns that would be extremely verbose with traditional loops, making it indispensable for sophisticated data transformations. In technical interviews, you'll likely encounter questions about array methods. You should be able to articulate the difference between map, filter, and reduce, and explain when to use each. Interviewers often ask you to implement your own version of these methods to test your understanding. You should know how to flatten arrays with reduce, group data, and solve problems by combining these methods. Another common question asks you to find an element or transform data using method composition. Understanding these methods deeply, beyond just using them, demonstrates JavaScript proficiency. Practice implementing them yourself and solving problems with them. Many interview questions involve real scenarios where you must choose the right method or combine methods effectively. Mastery of these fundamentals often determines interview success. The best way to master these methods is through practice. In the video description, you'll find links to a coding challenge site with exercises specifically designed for this tutorial. Start with basic exercises that focus on each method individually. Then progress to combining methods in realistic scenarios. When you get stuck, don't look at the solution immediately. Try different approaches and understand why they work or fail. Debug broken code to deepen your understanding. Finally, tackle challenge problems that mimic real-world scenarios you'll encounter professionally. As you practice, these methods will become second nature. You'll start seeing opportunities to use them everywhere in your code. This internalization is when you'll truly master array methods and write cleaner, more elegant JavaScript. Congratulations! You now understand map, filter, and reduce, 3 of the most important array methods in JavaScript. You know when and why to use each one, how to combine them, and how to apply them to real-world problems. These methods form the foundation of functional programming in JavaScript and are essential knowledge for any developer. As you continue your learning journey, you'll find these methods everywhere in frameworks like React, build tools, and libraries. Now it's time to practice. Take these concepts and apply them to your own projects. Start noticing where you write loops and think about how array methods could make your code cleaner. Subscribe to Elevate Learn for more tutorials that will take your JavaScript skills to the next level. Visit our website for exercise solutions, code examples, and additional resources. Thanks for learning with us, and happy coding!